Sample return.
There's been nothing like OSIRIS-REx in NASA's repertoire. I like to call it the Daredevil spacecraft.
10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of OSIRIS-REx, its 7-year mission to boldly go to the asteroid Bennu and back.
Welcome and thank you for joining us live from the Army's Dugway Proving Ground in Dugway, Utah. This is special coverage of America's first asteroid sample return mission, OSIRIS-REx, as it arrives back to Earth after more than 7 years traveling in deep space. I'm Lauren Ward, and joining me is Dr. Jim Garvin, Chief Scientist at NASA's Goddard Space Flight Center. He's a planetary geologist by training and also probably one of the most excited people around here today.
Lauren, literally, I'm over the asteroid.
Better than over the moon, over the asteroid. Well, I'm excited to share the stage with you today. We've got a lot to discuss and a huge adventure straight ahead. And for those joining at home, Jim and I will be taking your questions live throughout the show. You can send those our way by using the hashtag AskNASA on X, YouTube, and Twitch. And if you want to follow along this final guide to the mission at home, scan the QR code on your screen and check out NASA's Eyes on the Solar System, where you can view a complete 3D simulation and follow the OSIRIS-REx sample return capsule to the ground. And during the broadcast, you'll hear directly from the mission team, so listen very closely for those operational callouts. Before we get into the action, though, tell me, Jim, what are you most excited about?
Lauren, it's the masterpiece of engineering we have here. Just think about this. In 50 years, we've gone from bringing things on the moon back with crews to all robotic sample return for science that's literally beyond words. It's sublime. So we can't wait to see what we're going to learn.
We cannot wait. So OSIRIS-REx is an acronym for Origins, Spectral Interpretation, Resource Identification, and Security Regolith Explorer. Yes, it's a mouthful, but the mission describes an audacious objective. Send a probe on a long journey to an asteroid, map it, grab a sample, then bring it back to Earth for analysis. Following launch on September 8th, 2016, the plucky probe took an extraordinary route through the solar system until it reached the asteroid Bennu. Then, after more than a year of mapping the surface in exquisite detail, OSIRIS-REx made a careful descent in October 2020 to collect a sample. 3 years later, we are here at Dugway Proving Ground in the deserts of northeast Utah, awaiting that capsule containing the sample, which experts tell us is essentially a time capsule of the ancient solar system. We've got a great team joining us this morning as we experience this thrilling conclusion of this grand adventure. Sophia Roberts is located near our landing zone, and she'll be speaking with some key players in the mission. We'll also hear from James Traley, who will be tracking mission operations and bringing us real-time updates, essentially our eyes and ears inside mission control, which sounds to me like a good place to jump into the story. James, good morning. How are we looking?
Yeah, good morning, Lauren and Jim. It's already been a very bright early morning for all of our team members involved in this mission. Just a little bit further north from us, about 4 hours ago in Waterton, Colorado, the team met to assess the readiness to release the SRC from the main OSIRIS-REx spacecraft. And I'm very happy to report that they gave the green light, they gave the go command officially to release the SRC from the OSIRIS-REx. Let's listen in on what that command sounded like. That command came after more than almost 4 billion miles of spaceflight and years of planning, plotting, and dreaming about this asteroid Bennu. The SRC has now been separated from the main OSIRIS-REx spacecraft and is coming in rain or shine today. So team members are keenly aware of the weather conditions out on the range. It's looking pretty great for today. We did have a bit of rain the other day, which softened up that landing spot just enough to make the SRC land perfectly smooth on that surface. The temperatures are going to be around the 50s, 50 degrees Fahrenheit. Low winds out there, calm winds at the surface around 6 miles an hour, pretty light. Very clear skies this morning as well. As we were actually driving out, I saw a shooting star, a meteor, and in just a few moments, the SRC itself will be streaking across the skies as we begin to track it. Just a few moments ago, we heard the helicopters take off from here to head out to Wig, just at the edge of the landing ellipse. Our high-altitude plane is up in the sky, ready to take images in the infrared of our SRC, and we are here ready to go to cover all of today's mission events. I'm going to be right here with you all throughout the process as we get closer to that entry, descent, and landing. But for now, back to you, Lauren and Jim.
All right, thanks, James. We'll be back to you for mission status updates throughout the morning. For now, let's give you a quick geography lesson on where we are today. We are sitting about 85 miles southwest of Salt Lake City in the heart of the Dugway Proving Ground, a historic Army facility. In less than an hour, the sample will touch down in our landing ellipse at the Utah Test and Training Range, managed by the Air Force, about 13 miles north of where we're speaking right now. Mission teams have set up a clean room just 1 mile away from us, where the sample will end its journey today. Tomorrow morning, a C-17 aircraft will take off from the runway behind us and deliver the sample to NASA's Johnson Space Center in Houston.
Unbelievable.
Unbelievable.
Can't wait.
Oh, gosh. I can't wait to see that C-17. Oh, that's going to be breathtaking. We have a lot of ground to cover, and we'll be bringing you into the heart of the action. For all of NASA's many missions over the years, OSIRIS-REx lives in an extremely rare category. It not only ventured out into space with cameras and sensors, but it's bringing a physical sample of the ancient solar system back to Earth for detailed analysis. Mission planners selected a small asteroid called Bennu as their destination. Following a successful touch-and-go procedure to grab a sample on October 20th, 2020, OSIRIS-REx has been making its way back to Earth. It's been a thrilling ride, already packed with technical achievements and scientific discoveries. Today's historic landing continues that saga, promising exciting research ahead. Beside our main event this morning, we've got a ton of extremely cool stuff. We'll hear from a special guest astrophysicist whom you probably recognize more for his chart toppers. We'll speak with one of the helicopter pilots about his role in getting recovery teams out to the landing site and bringing the capsule back home. And we'll even hear from the cast of the film Asteroid City. And of course, we'll give you a front row seat to the mission itself, the science, the engineering, and why a mission to gather space rocks, well, rocks.
Right?
NASA's first asteroid sample return happens in less than 35 minutes. Let's now take you to Wig Mountain, where our field reporter, Sophia Roberts, is standing at the forward edge of the vast landing zone, where she joins us live now. Sophia,
Thank you,
paint us a picture.
Lauren and Jim. Now, it is a bright and chilly morning, but the excitement certainly is rising. Now, let me give you a lay of the land of what is going to happen today. The sample return capsule is going to hit the top of the atmosphere at approximately 8:40. It will descend through our atmosphere for 13 minutes before touchdown. Once it does touch down, our team with the recovery team will go to the sample or the capsule and start that carefully rehearsed recovery process. Now, I am on the edge of the landing zone that we call the ellipse. It is a huge landing zone that is larger than the size of Rhode Island. And behind me are the helicopters that will be taking those recovery teams to the capsule once it lands. Now, these teams are prepped and ready to go. We're just waiting for that capsule to arrive. Back to you, Lauren.
Wow, Sophia, I think she has the best seat
Oh
in the
my
house.
God, take me there.
I want to go there. All right, let's get some quick facts about the OSIRIS-REx spacecraft. Filled with fuel, the vehicle weighs more than 4,600 pounds. That's about the same size as 3 large cows. Did you know that, Jim?
I did not, and I'm afraid of those cows.
Let's stay away from the cows. With its solar arrays extended, the spacecraft is about 40 feet long, or the size of a short school bus. The solar arrays can power up to 3,000 watts, which is the same as a portable generator. Once on Bennu, the 11-foot robotic arm collected dust and pebble samples, while the cameras got up-close images of the asteroid. How about that? And then, of course, there's the SRC, or the Sample Return Capsule, the capsule that's separated from the main vehicle and is currently on its way to our landing zone in the Utah desert. So, Jim, I think importantly, the team can't just open up the capsule right on the desert floor, right? What happens next?
So next, we have to safe it, we have to bag it, we have to contain it, and transport it to the clean room about a mile from here. And in that clean room, we will actually bring the sample return capsule in, take off the back shell and the heat shield, and carefully arrange to nitrogen purge that special sample container inside, so it does not introduce any contamination from Earth, because we want asteroid, not Earth.
That's right. And I love missions like this because I find my own imagination just bursting with possibilities and questions. And so with about a little bit more than 30 minutes to go before the SRC hits the top of the atmosphere, we're going to take a few minutes to dive into the nuts and bolts of the mission itself. We've got a great mission overview to help explain. Take a look.
OSIRIS-REx is NASA's first asteroid sample return mission. It launched in September 2016 on a journey to explore a near-Earth asteroid called Bennu. After arriving in 2018, OSIRIS-REx spent nearly 2 years orbiting Bennu, mapping and studying its rugged terrain before carrying out its primary science objective. On October 20th, 2020, the spacecraft ventured to a small crater in the asteroid's northern hemisphere. It dodged jagged rocks and towering boulders and plunged its arm into the loose surface, excavating 6 tons of debris while collecting about 250 grams of material. OSIRIS-REx stowed its bounty and closed its sample return capsule. It bid farewell to Bennu in May 2021, embarking on a 1.2 billion-mile cruise back to Earth. Now, 2 years and 4 months after leaving Bennu, OSIRIS-REx is closing in on the place where its journey began. On September 24th, the spacecraft will approach to nearly 63,000 miles from Earth. It will power up and release its sample return capsule at 4:42 a.m. Mountain Time. The capsule must be jettisoned within a narrow time frame and at just the right angle to hit its target, an area of roughly 250 square miles in Utah's West Desert. Once the capsule is away, OSIRIS-REx will fire its thrusters to avoid colliding with Earth. At 8:42 a.m., the capsule will streak into the atmosphere at a blistering 27,000 miles per hour. It will race across the western U.S. and begin to glow with heat, allowing infrared trackers on the ground to chart its progress. As it pushes deeper into the atmosphere, the capsule will rapidly decelerate, subjecting the Bennu samples to a punishing 32 Gs. About 2 minutes after entry, it will slow to Mach 1.4 and deploy its drogue parachute, stabilizing its descent. The capsule will enter special use airspace at 8:46 a.m., almost 10 miles above the Department of Defense Utah Test and Training Range. Radar stations will lock on and track it to within 30 feet of its landing site. At 8:50 a.m., the capsule will extract and deploy its main parachute 1 mile above the ground. It will make its final descent at a leisurely 11 miles per hour, like a marathon runner savoring a victory lap, before touching down in the desert soil at 8:55.
Wow, I get chills every time I see that.
Me too.
Amazing. All right, so we know you have questions, so please continue to send them to us using the hashtag AskNASA. But before we go any further, I've got a question for you, Jim. Why is the mission called OSIRIS-REx? It sounds like a new hybrid kind of dinosaur or something.
It does, but it's actually the name of an Egyptian deity, a bird deity, but it means all the stuff the mission's going to be doing. So we're going to be searching for clues to the origins of our solar system chemically, looking at how we can ground truth all the data we have for asteroids from Earth, other spacecraft, right up close with samples. We're going to look at the resource potential of asteroids, metals, hydrated water and hydrated minerals, and also consider security of our planet from these kinds of objects. It's a big name with a big mission with many things it has to do. It's multiple missions in one.
Yeah, 3 missions in one, in fact. We know we have a global audience for this event, and throughout the morning we'll be taking questions submitted via social media. So let's take one now. All right, what do we have? At S4Mule_B asks, what's the significance of studying asteroids like Bennu for advancements in planetary science?
These are literally the time capsules of the early solar system with those bits and fragments we can never get here. So we go and bring them home to connect ourselves to the place we live, our solar system. So that's one of the big takeaways of this. We will read the clues of Mother Nature on how our world works in the context of all the rest of the planetary system.
Fantastic. All right, let's take another question. What do we have? All right, from at ndanger817. Approximately how large is the sample size, and what kind of analysis will be performed?
So it's about 8 or 9 ounces. It's about a size of a baseball and a half, and the kind of analyses are amazing. There are toolkits and instruments that can look at nanoscale characteristics that you wouldn't imagine. We could see the hairs on a foot of an ant, but we'll look at those in the context of another object in the solar system. So, wow.
Wow, indeed. All right, we'll be taking some more questions throughout the morning. Okay, so let us head back to the ellipse to talk to Sophia. I understand, Sophia, you've got a critical team member with you. Take it away.
Thanks, Lauren. Yes, I am joined right now by Stu Wiley, who is the Oscar, or on-scene commander, of this recovery mission. Thank you for joining me, Stu.
Thanks for having me, Sophia.
All right, so you are the person who kicks off this whole process before even the recovery team gets on the ground. Can you walk us through your process?
Yeah, so essentially what's going to happen is that once the capsule is undershoot, we'll have a better idea of where it's going to land on the range. And based on that, I'll know exactly what kind of weapon systems we used in that area, what kind of tests we've done in that area. So I'll know better what kind of hazards are in the area. Once I land on the ground, I'll do an initial sweep of the area and methodically move towards the capsule and mark any kind of hazards that I find, whether it be munition hazards, of course, and or the industrial hazards, and even the environmentally sensitive areas that we have out here. So.
All right, and how did you prepare for this today?
So preparation has been in the process for a long time. Between myself and Jasmine Nakayama, we've got 40 years worth of explosive knowledge. Most of it is on this range here, so we know the ranges very well. The team and the UTR have been working together, both Lockheed and NASA, and we've been doing rehearsals so that we are more familiar with their capsule, and they're more familiar with our terrain here as well. Yeah, so.
And this is an active proving ground here. So what are the other steps that we have to ensure that our teams are safe?
Yeah, so at the Utah Test and Training Range, we do have a lot of different hazards out here. Like I said, the weapon systems that we test. We're going to keep them safe from that. We have, again, done many of the preparations with them already. They've taken safety briefings. They've been briefed on the actual items that we've dropped out here in their range safety brief. One of the hazards that we're going to be dealing with, though, is the helicopters that you see behind us, and they've been through practices getting on and off the helicopters and working in and around them. But I think the biggest hazard that we're going to have is slipping. We had some recent rain, so that I think is going to be our biggest hazard, but it could be fun too. So.
Well, wonderful. I know that you have your last preparations for the day, so I'm going to let you go, and thank you very much for joining us.
Thank you, Sophia.
Thanks, Sophia. Stu's got a big day today.
Oh, my goodness.
A lot to do. All right, Jim, we know we have space fans from all walks of life all over the world. One super fan in particular is a well-known astrophysicist with an atypical side hustle. But I'm guessing you know more him probably.
To all who worked so incredibly hard on this mission, especially my dear friend Dante, with whom we already created this beautiful book. God bless you all.
Speaking, joining us is NASA's Lord.
Defense. How does it do that way out there?
So actually, OSIRIS-REx gave us some really important new information about an effect, a force that occurs on asteroids called the Yarkovsky effect. And what that really is we know there's gravitational pulls on the asteroids, and we can predict that with our trajectories, but Yarkovsky effect says that the sun's radiation heats up one side of the asteroid, and then as the asteroid rotates, the radiation radiates off into the deep space. And that actually kind of acts as a force that kind of pushes back against the forward trajectory. And so it changes our predictions on where the asteroid might be. Over time, it really makes a difference. And OSIRIS-REx gave us some fantastic new measurements on that effect.
Unbelievable.
Wow, that is truly unbelievable. Nobody appreciates the planetary defense aspect more than me and Jim.
Yeah, we want to be safe.
Big fans, big fans. Really quickly here. You know, this isn't the end for OSIRIS-REx. What's next?
Yeah, so really exciting. Now that the spacecraft has released the capsule successfully, about 20 minutes after that release, we're now repurposing the spacecraft for a new mission called OSIRIS-APEX, where APEX stands for Apophis Explorer, and it's off on its new mission to explore the asteroid Apophis, which is going to have a close flyby of Earth in 2029.
All right, stay tuned, everybody.
Unbelievable.
That is fantastic. Well, thank you so much, Lori, for joining
Lori.
us. You're going to stick around for the show, right?
Oh, absolutely.
Absolutely. Okay. This will be the biggest U.S. sample return since the Apollo mission to the moon. On the arrival of the historic OSIRIS-REx sample, we celebrate that the Japanese Space Agency, or JAXA, has already visited 2 asteroids, Itokawa in 2005 and the asteroid Ryugu in 2019. The missions Hayabusa and Hayabusa 2 proved that it could be done and paved the way for today's ambitious goals of this daring enterprise. All right, let's send it back over to James for an update on mission operations. Go ahead, James.
Yeah, thanks, Lauren. So everything continues to be nominal. I've been tracking the mission status here. Everyone looks dialed in, ready to go. You saw a few moments ago Sophia with Stu Wiley, our on-scene commander. today. And as I mentioned earlier, just a few moments ago, actually I guess a couple hours, released from the main spacecraft. When that release took place, it was given an initial spin, which kind of preserves its angular momentum, its speed as it's coming in to Earth's atmosphere. It's similar to throwing a perfect spiral on a football, and teams are hoping for that perfect touchdown.
Into a time when the sun and planets were forming over 4.5 billion years ago. Samples from OSIRIS-REx and Artemis could rewrite our understanding of the evolution of the solar system. And that's a look at your Artemis Moon Minute. Boy, Jim, how can you not get excited about that?
Oh my gosh.
Oh boy, that's going to be so cool. All right, Sophia is standing at the forward edge of the recovery zone with an update. Take it away, Sophia.
All right, thank you, Lauren. We are under 20 minutes away from EDL. That is entry, descent, and landing. And I don't think there's anyone here on planet Earth who has anticipated this day more than the principal investigator of the mission, Dante Loretta. Thank you for giving us time here today.
My pleasure. It's great to be here.
All right, so you are here on Wig Mountain because you are on the recovery team.
That's right.
Can you walk us through what you're going to be doing today?
So I'm part of the environmental sampling group. From day one, this mission has paid attention to keeping that sample pristine. And we're going to come down. We had some rain on Thursday. Most likely we're going to be encountering mud out there. We're also interested in the air quality and any water that might be standing, just so in the very rare event that any of that material somehow comes into contact with the sample, we have a record of it and it won't compromise our science.
Oh, wonderful. And I think one of the really exciting things about a mission like this, especially with you working with the University of Arizona, is that you're partnering with educational institutions. So can you talk a little bit about the legacy?
In every major NASA planetary mission since then. And really the best part of having a university lead a program like this is that it's a great training ground for the next generation. I've been on this program almost 20 years, and I've watched multiple generations of students grow up, become professionals, either join the team. We always take our team members on board when we need to fill roles, or off into other careers in aerospace engineering, science, and many other disciplines.
It's really great to foster those incredible questions about our universe.
Absolutely.
And I know that you need to get back to your team to go on that recovery process.
The moment's almost here.
Yeah, so thank you so much for joining us, and best of luck out there today.
Thank you.
All right, back to you, Lauren.
Great, thanks, Sophia. Wow, I can't wait for Dante to get his moment in the sun.
Goes Dante.
That is amazing. All right, so Jim, the whole OSIRIS-REx spacecraft is not coming back today, right? It's
Absolutely.
just a part of it.
That's right. This is the whole spacecraft, 40 feet long, the size of a school bus. But this special little thing here, the sample return capsule, is bringing home the goodies. And that's what we've just released, and it will be entering the atmosphere, and you'll be hearing all about it. And the samples were collected at the asteroid back in October of 2020 from this TAGSAM thing that inserted them in the capsule, and the capsule was released. So that's what comes home. The rest of this goes on to Apophis.
That's right. We just heard Lori talk about that. But let's move over and take a look at this replica SRC capsule. Now, this was an engineering model that was used in tests a few weeks ago for a drop test. Can you talk a little bit about the engineering of this?
That's right. This is a very special spacecraft, just like a small version of what we use to bring crews back when they come back home to Earth from the space station. It has a heat shield. It's about 30 inches across, so it's pretty big. It weighs over 100 pounds. Has a back shell, and inside it has the goodies, the sample return canister and the small sample canister. So this is the vehicle that brings those samples protected from all those changes in environment from the top of the atmosphere, 13 minutes of descent to the touchdown point that we're waiting for today. This is a very special spacecraft.
It absolutely is, and it also was used in a drop test, as I mentioned. Let's take a look at some of that footage now.
Right. So just a couple weeks ago, we dropped this replica, this engineering test unit, from 5,000 feet with a parachute deployment, and went through all the operations, the choreography we need to actually make sure we can do it today. And that's what's going to be coming up. And it worked wonderfully. We inflated the big 24-foot parachute. It floated down to the surface at 11 miles an hour. We went through all the recovery operations, the safing, the bagging, and the containment to come over to the clean room here, where we'll be doing that today to make sure those samples are from Bennu, so we can study them here on Earth and not contaminated by our wonderful Earth.
That's right, and you know it's the actual SRC that they use because it is covered in dirt, as you can see on here.
This is dirt, scratch marks.
All the scratch marks, yeah.
It's a rough ride,
It's the real deal.
but we need it to come home. This
Absolutely.
is a real sort of homecoming.
Right. So there's a lot of science in missions like this. Not only is the SRC a treasure chest with material from the ancient solar system, but the mission itself is a platform for vital research about a range of things that you might not have expected.
SciFly's mission is to collect visual, infrared, and spectral data on spaceflight vehicles, including the OSIRIS-REx sample return capsule on its return to Earth. This gives engineers and scientists unique insight into our most challenging questions about hypersonic fluid dynamics by providing data critical to flight safety systems. The scientifically calibrated in-flight imagery team uses ground-based sensors and instruments flying on various aircraft to image asteroid sample returns, launch abort systems, parachute tests, rocket launches, and capsule returns, including Artemis 1 on both launch and reentry. The data we capture provides engineers with information on vehicle performance relative to what computational tools and wind tunnel tests predict. It takes extensive planning to get it right. Upon its return from the asteroid belt, the OSIRIS-REx capsule will be traveling at 12 kilometers per second, or about 27,000 miles per hour. That's nearly twice as fast as objects coming back from low Earth orbit, and it will be among the 4 fastest human-made objects ever to fly in Earth's atmosphere. In partnership with the Japan Aerospace Exploration Agency, Rocket Technologies International, and universities in Australia and Germany, SciFly is coordinating 3 ground stations and 4 aircraft to collect data on the sample return capsule's trajectory, heat shield performance, and the plasma environment surrounding the capsule as it speeds to the surface, all of which will help NASA understand its performance and help future planetary entry missions succeed.
Joining us now is NASA's Kate Calvin, Chief Scientist and Climate Advisor. Kate, thank you so much for being here.
Thanks for coming.
Thank you for having me.
It is wonderful to have you. All right, so as NASA's Chief Scientist, you're looking at the big picture. How much teamwork across the agency has made to, a day like today a possibility?
A mission like this takes a big team, both within NASA and without. So outside of NASA. So the mission is managed by Goddard Space Flight Center in Maryland. The sample is going to be going to Johnson Space Center in Texas after it leaves here. Marshall Space Flight Center in Alabama does the overall program management. Outside of NASA, we have collaborations both in industry, academia, and international. So Lockheed Martin is doing built the spacecraft and doing flight ops. Kinetics is doing navigation. Wow. We have a science team led by the University of Arizona. And then we have
recovery operations. Helicopter 1 has departed WIG to station keep outside the landing ellipse.
We got a confirmation that helicopters 1 and 2 have just taken off. Very exciting. All right.
So, Kate, one other thing. As an earth science and expert on how our planet works in climate, can you tell us how this asteroid mission and the samples we return might impact how we understand life on Earth, how it evolved, and how climate issues now might be involved?
Yeah, so this asteroid Bennu may record some of the earliest history of our solar system. So scientists are looking at it to help us understand planet formation and the origins of water and carbon, which led to life here on Earth.
That's incredible.
That is incredible. And, Kate, I know you've been to several launches. That's our typical bread and butter here at NASA. But this is more of a homecoming. How does that feel to you?
It's great. The environment here is so nice, being with the team and thinking about, this spacecraft launched 7 years ago. And now there's all this amazing science just around the corner.
Can you believe it? The team has really been working hard. And are you going to stick around for the show?
Awesome.
Fantastic. All right, well, Kate, thank you so much for joining us.
Thank you.
Thanks, Kate, for all you do.
Thank you so much. This seems like a perfect time to dig into some more information about Bennu. Bennu isn't part of the main asteroid belt. It's a NEO, a near-Earth asteroid with an orbit that occasionally brings it in close proximity with us here on Earth. Bennu is about 500 meters in diameter, which is taller than the Empire State Building. It rotates upside down on its axis compared to Earth, with a tilt of over 177 degrees. Scientists chose to study Bennu because of its
recovery operations. Helicopter 2 has departed WIG to station keep outside the landing ellipse.
All right, so you just heard that they have departed WIG. Excellent
Whoa.
Progress. Fantastic. Woo. All right. Moving on, it isn't as smooth a surface as we initially thought. It's actually covered in pebbles and marked by these large rocks and boulders nearly everywhere. One boulder in particular that OSIRIS-REx had to navigate around was nicknamed Mount Doom and was the size of a 2-story building. Bennu holds the Guinness World Record of the smallest object to be orbited by a spacecraft. How fun. Now let's get an update from Sophia, who is standing on the edge of the ellipse. Take it away, Sophia.
Okay, 2 of the helicopters have already just departed, so the team is already in the recovery process, or at least the beginning phases of it. But right now, we are waiting to hear precisely where the capsule is going to land before the rest of the teams head on over to that location. Now we are about under 10 minutes away from the capsule hitting the top of our atmosphere, and we are eagerly anticipating this largest sample of ancient solar system material that we have received since the last Apollo mission in 1972. So that is 51 years since we've had such a pristine and large sample of ancient solar system material. It's a really big day for science, and we're just in the beginning phases of today, but we are certainly excited to hear about what will happen and see those parachutes finally descend through our atmosphere. So yes, we're certainly excited, but this is just one phase of this amazing mission. I'm going to send it back to you, Lauren.
See the operational milestones we're expecting throughout the morning. SRC separation already happened, and the capsule is now heading for its rendezvous with Earth's atmosphere. Jim, it always appears like these operations are simply inevitable. You know, we grabbed the sample, we flew it back to Earth, we're headed in for landing, but it's never that simple, is it?
No, not at all. And so we have a lot of critical events that take masterful engineering. We have to hit the top of the atmosphere, transition through a high G, high heat environment, go from 27,000 miles an hour down to eventually 11 for that safe landing. All these things involve changes in environments, forces, things that could disrupt our sample and change them, which we want to document. And so we really want to understand this and finally bring it to rest so we can then bag it and encapsulate it so we can eventually get the sample into our clean room here. So we're ready to transfer tomorrow to Houston to the Johnson Space Center. So this is a big process, well rehearsed by a masterful team.
Absolutely, and contains, work from thousands of individuals who are making this happen. All right, so we know that you're submitting questions from all over. Let's take a few more social questions. All right, what do we have? At Dev Saran at 5342461. What are the preliminary steps to take to test a sample? The preliminary steps.
So first thing we do is, of course, bag it here and get it into the clean room and get that sample, that sample canister inside the sample return capsule, get it under nitrogen purge, meaning we flow nitrogen gas so no Earth atmosphere and microbes get involved. That'll happen today. Period of a few hours, and then tomorrow we transfer to the Johnson Space Center in Houston, Texas, where all the fun happens at the Astromaterials Curational Facility, where we've done moon rocks and samples of interplanetary dust and lots of things. Those colleagues in a special clean room perfectly designed for this mission will unpack those precious samples in the small sample canister, the small device that was used on the end of the TAGSAM, and they will go through a process to get it checked out, to do early reconnaissance, and to protect it very carefully.
That is incredible, and they built that whole clean room. No other asteroid samples before.
Right.
This is the first one.
First ever.
First ever. As the SRC approaches the edge of Earth's atmosphere, we are just moments away from the world's largest ever asteroid sample return. Jim, what are you feeling right now?
I am literally tingling all over with exhilaration. This is a small step for a capsule and a giant leap for science.
It really is, and if that's one thing we can impart, that is it. This is a huge, huge milestone, a great achievement. So this is it. We are just 15 minutes away from the OSIRIS-REx sample return, a journey of 7 years and nearly 4 billion miles. The work of thousands culminates in this moment. Let's turn it over to our mission commentator, James Traley, to take us through the final moments. James, we're all yours.
Yeah, Lauren, buckle up and get ready for the ride of entry, descent, and landing. This is 13 minutes of crazy descent, punishing crazy deceleration of our spacecraft, starting at 27,000 miles per hour when it enters into Earth's atmosphere, and eventually slowing to a leisurely 11 miles per hour as it descends and lands on the Utah Test and Training Range.
Recovery operations, helicopters 1 and 2 have arrived at the holding location.
So good news, our helicopters are ready to go and begin those recovery operations just as soon as we have confirmation of touchdown here. And as the sun begins to rise in the west coast, the SRC is going to be streaking across the atmosphere above San Francisco, California, about 82 miles in altitude. It's going to be coming in hot, over 1,000 degrees Fahrenheit, almost a couple seconds after it hits that atmosphere. That's about half as warm as the surface of the sun, to give you some context. But don't worry, our sample will be safe and sound within. We have a heat shield, which is made of a phenolic impregnated carbon ablator. It's a very fancy term to describe what's going on with this heat shield. It basically ablates away or burns away any kind of heat flux that develops on that outer shell, making sure that our sample is safe and cool within. Similar technology that we use with astronauts coming back from the moon or any kind of other landers that we have going into planets and moons. So we're just a couple moments away from this key moment. It's going to be very exciting next couple 13 minutes here, and you'll hear a couple callouts come in from just next door in our mission operations team as they begin to get us ready for this key moment. It's a journey of 3.86 billion miles getting reduced to the scale of mere miles, 82 miles above the surface of the Earth in San Francisco. A couple key events are going to happen as soon as we get into the Earth's atmosphere. Very quickly we're going to deploy our drogue parachute. This is for stability, stabilizes our descent, and make sure that we are continuing to target that landing ellipse that is here in the Utah Test and Training Range. It is a 36.5 by 8 mile landing ellipse that is here, marked out for that recovery operation. You see on your screen now the mission ops team eager at the edge of their seats for that first call out of Earth atmospheric entry. Very exciting moment coming up in just a few seconds here. We're about 20 seconds away. You see the team at Lockheed now, all standing ready on the edge of their seats. This team, I'll remind you, just a few hours ago gave that command to release the SRC on this long journey. It's been on its own for 4 hours. There's nothing we can do at this point. It's coming in, rain or shine.
EDO milestone. The SRC has entered the Earth's atmosphere. UTTR tracking assets have acquired.
And here we go. Start your stopwatch right now. We are 13 minutes of entry, descent, and landing. We have that expected milestone of entering into the Earth's atmosphere. We can see the team at Lockheed, and we actually have a visual now. This is from our infrared tracking camera on the WB-57, our high-altitude plane, at about 47,000 feet MSL, mean sea level, getting a great view of that SRC heating up as it enters into Earth's atmosphere. The punishing deceleration that spacecraft, that SRC, is experiencing right now, as it comes in at about 27,650 miles an hour. You can see it glowing brightly in the sky. And in just a few moments, we're going to reach peak heating and peak deceleration. That's at 32 G-forces, punishing G-force on our SRC. A phenomenal view of that streaking SRC coming in across the sky. At this point, we have entered in over San Francisco, California, and are very quickly going to be approaching the Utah Test and Training Range just a little bit further to the east. Entry was at
EDO milestone. SRC is experiencing maximum heating and maximum deceleration.
So you just heard right there, we're experiencing that 5,000 degree Fahrenheit maximum heating, burning scalding hot on that heat shield that is protecting our sample within, and maximum deceleration that is at 32 G-force, punishing deceleration from Earth's atmosphere, the drag forces that are acting on that SRC. Once again, as I mentioned, that sample is safe and sound within that SRC, that sample return capsule, as it comes in, burning through Earth's atmosphere. You can see our high-altitude plane searching for that SRC. You can see it faintly on your screen there. Our next milestone, we'll be expecting that drogue parachute deployment. That'll be at about 102,300 feet altitude. And as I mentioned before, that will stabilize our descent and slow us from hypersonic to subsonic speeds as we continue to target the Utah Test and Training Range.
Expected EDO milestone. SRC commands drogue parachute deploy.
So we heard that command to deploy the drogue parachute. We're waiting to see that visual confirmation, but that is at 102,300 feet. And a side note, at this time, 8:44 a.m. Mountain Time, the OSIRIS-APEX spacecraft is at its closest approach to Earth. That will be on to its extended mission, visiting the asteroid Apophis in the year 2029, continuing this incredible mission at another world. And in just a few moments, we should enter into special use airspace at approximately 8:46 a.m. That's going to be at 10 miles off the deck here at Utah Test and Training Range. You can still see that SRC on your screen very faintly in the distance. Still quite warm, that fireball that literally was a ball of plasma just a few moments ago when it first entered into the Earth's atmosphere. That SRC is nearly 3 feet wide, 1.6 feet tall. It's a small object, so quite a a challenge to track this as it comes searing into Earth's atmosphere. And in just a few moments, we should be entering into special use airspace. This area was specifically chosen for this mission. It's a wide open, vast desert space, relatively flat, perfect to land this sample today. We did, as I mentioned, have a couple days of rain here leading up to this event, so the ground is a little bit soft. You can see our SRC. Streaking in. This is from our high altitude cam. Our next milestone, we should be expecting main parachute deployment at around 8:49 a.m. Mountain Time. That will be at around 5,000 feet elevation. We continue to track with our high altitude camera here. As I mentioned, that sample is thermally isolated within that SRC, a very complex labyrinth network of piping and tubing leading into that sample canister within, that just a few years ago was on the other side of the solar system from us sampling an asteroid Bennu. The team has incredible precision on this mission as well. Just a few days ago, on the 17th of September, they did their final trajectory correction maneuver, TCM-12. This corrected our velocity by 3 millimeters per second. We see
PDL milestone. We have confirmed parachute deployment.
Wow, and after an exhilarating streak across Earth's atmosphere, we have parachute deployment. You can see just a sigh of relief from the team. I can hear some applause here. There is that orange creamsicle colored parachute, just a delight, a sweet delight to see in our sky here over the Utah Test and Training Range. A phenomenal view, just wonderful to see that deployment. That is at around 5,000 feet elevation above the Utah Test and Training Range. And now this is like a marathon runner savoring that last lap here as we approach the finish, that landing in the Utah Test and Training Range. Wonderful to see that. We continue to track. This is with our high altitude camera still, that WB-57. And we should have a great view from here on the ground. We've got a variety of different tracking assets. And you saw Sophia out at the edge of that ellipse watching from Wig Mountain. The team there could potentially have a wonderful view momentarily as well. We'll continue to descend. Our next altitude descent will be at about 4,000 feet. Just a few minutes away from getting that sample from the other side of the solar system, from the surface of asteroid Bennu at sample site Nightingale to the rugged terrain of the Utah Test and Training Range. It looks like winds are relatively low. Not a lot of rocking back and forth. Those parachutes seem to be perfectly smooth coming down, that parachute there. Continuing to descend, the slight little bit of tilt back and forth of our SRC as it comes to its resting velocity of 11 miles per hour as it makes that final descent. That parachute deployment was given internally by the spacecraft. All of what you're seeing now is autonomous on board that SRC. And once that successfully lands, the teams will begin the next crucial phase of this mission, the sample recovery operations. They've been rehearsing for this moment for months, literally years really, leading up to this key moment, and are ready to begin those operations to get that SRC into our portable clean room here and extract that sample canister within. According to my watch, we're about 5 minutes away from landing with our SRC. And as we heard a few moments ago, helicopters 1 and 2 are already staged and ready to begin those recovery operations just as soon as we have confirmation of touchdown. This is a variable clock, so this could be a little bit faster, a little bit slower as we get closer in. This wind speed here is a variable that is quite hard to predict, especially once you're high up in the atmosphere. We did release a weather balloon earlier on this afternoon, or earlier on this morning rather, to get a profile of our atmospheric conditions. The team puts those into various models as they prepare for this key moment. But once again, they are a little bit hard to predict, a little bit of variability, so we may kind of bounce around a little bit on that predicted OSIRIS-REx sample return capsule touchdown time. We've got visual on the sample return capsule under parachute, that orange creamsicle color parachute, really bright in the morning light over the Utah Test and Training Range. A great view of the SRC we can have now from our helicopter as it continues to make its final descent to the terrain below. And once again, just setting the context for this, when we first hit the top of the atmosphere, we were at 27,650 miles per hour. We are now leisurely decelerating under our orange parachute to 11 miles per hour. Incredible amount of deceleration there, as Earth's atmosphere really helped us out quite a bit, getting that initial deceleration, our drogue parachute initially stabilizing our descent, and then ultimately that main parachute bringing us home. You can see right in the center of that crosshair, that is the parachute with the SRC dangling beneath. The team on the WB-57 doing a
DDL
great job.
milestone, we have touchdown. I repeat, DDL. SRC has touchdown.
And touchdown of the OSIRIS-REx sample return capsule. A journey of 1 billion miles to asteroid Bennu and back has come to an end, marking America's first sample return mission of its kind and opening a time capsule to our ancient solar system. Unofficial touchdown time, 8:52 a.m. Mountain. And the team can now breathe an immense sigh of relief. We now have the sample return capsule, the SRC, containing pieces of the asteroid Bennu. You see the reaction there just moments ago as they got that sample back on the ground. This is the team at Lockheed celebrating that momentous achievement of getting that sample from the other side of the solar system at asteroid Bennu. When we took that sample, we were over 200 million miles away from us here on Earth. The long journey back, 1.2 billion miles from asteroid Bennu, back to here with that sample, has just come to a dramatic close. And a little bit ahead of schedule, too. The SRC landing about 3 minutes ahead of when we had originally predicted. It was in a rush to get back here, carrying amazing amount of scientific information within. The team is eager to crack that SRC open, get the sample canister within, and begin the process of understanding the origins of our solar system and potentially the origins of life. We're not in the clear just yet. A key piece of the mission is about to get underway. This is the recovery operation phase. Once the team has officially confirmed the exact touchdown location, they'll be flying out on 4 separate helicopters and will operate much like a Formula One pit crew, if you will, to recover the SRC, take environmental samples at the landing zone, the LZ. Everyone has a role to play. It's going to be simultaneous action as they get that SRC recovered and begin to do an environmental safety sweep, collecting samples along the way. You see our mission ops team just next door. I once again remind you that the sample canister itself is not actually going to be opened here at Dugway. The next phase of the operation is simply to get that SRC into the portable clean room that has been specifically set up for this recovery operation. The team will then remove the heat shield protecting the SRC and its precious cargo within the entire descent through the entry, descent, and landing, remove the back shell, and then extract the sample canister within the tag sim that just a few years ago collected pieces from the asteroid Bennu. Today, the goal is to get the sample canister.
Recovery operations. Helicopters 3 and 4 are leaving rig for the landing ellipse.
You see some big smiles from the team there. They are getting those helicopters out to the landing ellipse now to begin those recovery operations. The first person to approach the SRC is Stu Wiley, our on-scene commander. You see the helicopter, the last of them, taking off from the Wig Mountain just at the edge of that landing ellipse. These helicopters will have a trip out to find that exact touchdown location of the SRC and begin those recovery operations. Stu Wiley, our on-scene commander, will be the first person to approach that SRC. He'll do an environmental safety sweep checking for unexploded ordnances. As he mentioned in his interview earlier with Sophia, he understands this range. He's worked here for a number of years. He will brief the team on any possible dangers that would be presented to them as they begin those recovery operations. And then a team member from Lockheed Martin will begin to take gas and thermal readings once the area is safe of that SRC to determine whether or not it is at safe operational levels for the rest of the team to begin the recovery operations. As I mentioned, this is going to be simultaneous action. The team has prepared. They're all going to be wearing these bright white UV shirts, sample recovery shirts. You'll see them walking out to that sample in just a few moments here once those helicopters land. A great view once again from our high altitude plane. You can see the parachute there next to our SRC. There is a possibility that there could be unexploded ordnances from that parachute. There is a mortar inside that is to fire to disconnect the parachute from the main SRC to help it come to a final rest. It's a bit challenging to see from this perspective, but there could be some potential roll marks or skid marks as that SRC came to a rest on the rugged desert surface below. As I mentioned, we did have a bit of precipitation here the other day, so that should make for a nice soft surface for that SRC, so it probably had a nice clean landing there. The team will assess as they get out there and check exactly how our conditions are for the SRC and the surrounding area. You heard Stu mentioning the team might need to wear some boots. The operations could get a little bit slippery as they begin to recover that sample. And this is a pristine sample from the ancient solar system and could hold the clues to how everything around us came to be, from the formation of the planets to the origins of life here on Earth. Needless to say, this is precious cargo, and the recovery team is fully aware of the gravity of the situation and the importance of what they're about to do today with these recovery operations. You can see it looks like our parachute has come to a stable rest. The winds were pretty low today, so it looks like it is not billowing at all. It is almost perfectly flat, at least from this perspective, on that desert terrain. And throughout all these operations, the crew member safety is paramount. So you'll see the team probably huddle up a couple times as they begin these recovery operations to make sure that everything is safe and continues to be nominal as they make their initial safety sweep. All of this recovery should be a very quick process usually. They've rehearsed for this again for months. They've been out here all summer really rehearsing for this moment. They did a drop test last month. They've also had numerous rehearsals actually practicing containing that SRC, getting it on a sample carrying fixture.
Recovery operations, WV has located the parachute on the ground.
You just heard that confirmation from that high altitude plane locating that parachute on the ground. This location info will be relayed to our team members aboard those helicopters as they begin their approach out to the landing zone. We do have that confirmation from the high altitude plane, as you just heard. We're still working to get confirmation from our NASA helicopter. It is on its way out to that landing zone as we speak, so we should hopefully have that view up in just a few moments. You continue to see our team just next door, the mission operations team, all looking at that high altitude view. Right in the middle there, just pointing around with the UV white shirt, is Rich Witherspoon from Lockheed Martin. He has been leading a lot of these operations for the past couple months. He's been preparing the team for this exact moment and really has been a great leader helping us get ready for these recovery operations. Yeah, so this ellipse here, this landing zone, is a quite large setup here, and this was chosen intentionally for this mission. It's about 37 miles by 9 miles total, this landing ellipse, out in the Utah Test and Training Range here in Dugway, Utah. This is an enormous facility. As you heard earlier, it's about the size of Rhode Island, all in all, this whole facility. It's relatively flat, very smooth terrain, this desert surface. So it's perfect for bringing something back and having that nice, safe landing on the desert surface. Just a few years ago, the OSIRIS-REx spacecraft back in 2020 made its tag attempt, the touch and go attempt to actually collect the sample that has now landed in this desert. When it did that, it was only at the surface for just a couple seconds, descending at a speed about 11 centimeters per second, just a little bit faster than a baby that is crawling. It's a very slow pace, but they were able to successfully get that sample and bring it from the edge of our solar system back to us here at that Utah Test and Training Range. You can see our full screen view here of that high altitude view, looking at the parachute at rest on the surface of the desert. This is at the Utah Test and Training Range. It's a wide open expanse here, and the team has this positional info, and they'll be relaying that to our helicopter teams to begin those recovery operations. And what you'll see in a couple seconds here, the recovery team, the recovery crews are responsible for securing the sample return capsule, the landing site around it, and helicoptering the SRC to a portable clean room that's located just next door here on the range. And just a little bit later on, it's going to be attached to a 100-foot long line beneath one of the helicopters, and then will actually be flown to the clean room. This was determined to be the best possible way to transport that SRC safely and efficiently, to get it on a nitrogen purge and maintain the pristine nature of the sample within. As I mentioned, this is an enormous ellipse, 37 by 9 miles. It's a large expanse to cover by car. It's a very bumpy ride out there as you kind of start to make your approach across this rugged terrain. With the helicopters, it will be approximately a 20-minute flight back with that SRC. They take it at a nice slow pace, effectively parading the SRC around, just giving it its last big moment as it is served its purpose officially at this point of getting that sample canister safely here to Earth. Once we actually land and begin those recovery operations, you'll see a lot of team members out beginning to take samples, both air and also soil samples from around the area. These are places of interest for the sample curation team that will actually open up the sample canister in the coming days down at the Johnson Space Center in Houston, Texas. They have a phenomenal sample curation facility there, and these samples from asteroid Bennu will join a historic collection of other asteroid materials, including samples from the Apollo mission, samples from both the Stardust and Genesis missions, as well as Antarctic meteorites that were collected by our scientists. In the coming days, we'll actually know exactly how much sample we got back from Bennu. The original mission requirement was 60 grams of pristine sample from the asteroid surface. Based on some very clever engineering, the team believes that they have potentially 250 grams, or 6 times that mission requirement, inside. And so we just heard that unofficial touchdown time was at 8:52 a.m. Mountain Time here at the Utah Test and Training Range in Dugway, Utah. If you're just joining us, you see that view right now from one of our high-altitude planes observing our touchdown location. On your screen just above that crosshair is the orange creamsicle-colored parachute that brought us the last part of our journey down to the surface of the Earth. You heard from Jim earlier that that main parachute is about 24 feet across. Fairly large parachute that helped us decelerate on our last leg of the journey. And so we just heard a confirmation actually that the main parachute deployed much higher than was originally anticipated. It was originally supposed to deploy at about 5,000 feet elevation, but it actually deployed at around 20,000 feet, so much higher up. So that would explain our kind of earlier touchdown time than expected here. Still has touchdown on the Utah Test and Training Range. Team members continue to fly out to this location aboard helicopters. As I mentioned, there are 4 recovery helicopters in total. The mission operations team is continuing to monitor the situation. They're the ones who are relaying us that info about that high parachute deployment, that 20,000-foot parachute deployment. They're going to be assessing the situation from their end here, relaying any possible info over to our recovery teams as they begin to make their trip out to our SRC. One of the first goals once the team gets out there is to safe and stow the parachute. Begin to mark places of interest, as I mentioned, for that curation team to begin sampling. This is all a very well-coordinated machine, very well-oiled machine that operates in tandem. They've rehearsed extensively for this moment. So we just heard from the team in that mission operations room that they have visual of the parachute, that orange parachute that you saw on your screen moments ago, but we do not yet have visual confirmation of the SRC itself. The team is continuing to survey the region, looking for that sample return capsule.
Recovery operations. Kilos 1 and 2 are in the area of the landing site and are in a search operation.
So you just heard that call out from Tim Preiser, who you see on your screen there from the mission operations room. He just announced that Helos 1 and 2 are now at that landing site. They're pointing out something on the screen. I see some smiles. It seems like we might have potentially some more information on that SRC in the coming moments. Helos 1 and 2 will be surveying this region, looking for both that SRC and also eyeing up the region, looking at that parachute that was deployed.
Recovery operations. All of the ground supported vehicles have left rig and are in pursuit of the landing zone.
So some more team members are going to be heading out to that landing zone as well in support of those 4 helicopters that will be the main group recovering that sample. The main helicopter will be actually attaching that sample return capsule once the team has it located and ready to prepare for recovery operations. They'll load that on long line. You can see some, once again, some team members pointing at items on the screen here. We'll hopefully get confirmation in the coming minutes of that SRC location. Tim Preiser pointing at the screen now, wondering if he has any more information for us on where that sample return capsule location would be. We do have visual confirmation of that parachute, as I mentioned. Rich Witherspoon radioing out to the team. And now we have a view from our helicopter of the landing location. You can see the sample return capsule dead center on your screen, that kind of dark gray black object right there. And then just to the right of it, a little bit below, is our parachute. It appears to be resting on the surface. We're getting a zoom in now from our NASA helicopter. And you can see now the SRC. At last, we have a visual of it on the surface of the Utah Test and Training Range. I'm sure that is a pleasant sight for the team to see.
Recovery operations. Helo 2 has visual on the SRC. I repeat, SRC has been located.
And we have visual on that SRC. It appears that the parachute has also disconnected. It's a little bit off from that SRC, disconnecting from the back shell. The SRC appears to be resting on its nose, that heat shield that protected it the whole way down through that entry, descent, and landing. Lockheed is celebrating that moment. I'm sure they are breathing another sigh of relief here. It's been a wild morning for everyone involved. They've been up since the crack of dawn, just a little bit further north from us in Waterton, Colorado. They gave the go command to actually release that SRC that you see on your screen right there from the OSIRIS-REx spacecraft about 4 hours ago. It then ventured entirely on its own and now sits on its own for us here in the Utah Test and Training Range. So now that we have visual, the teams should be able to begin the recovery operations in just a few moments. As I mentioned, that first person on scene will be the on-scene commander, Stu Wiley. He'll be doing an environmental sweep. We're getting a nice close-up view. You can see the parachute disconnected. You can see some of the wiring of it there, just a little bit off the edge of our SRC. The SRC looks quite charred up from that entry in. That was expected as we heated up to temperatures over 5,000 degrees Fahrenheit upon entry into Earth's atmosphere. You can see a great visual of some of that rugged terrain out there. Just a sweeping expanse, very panoramic terrain at the Utah Test and Training Range. It's a great location for us to land this sample. The team looking a lot more relieved now that we actually have visual. And we should be able to begin those recovery operations shortly. Inside that sample return capsule are pieces of the asteroid Bennu. We'll be getting access to those samples in just a few days and actually seeing exactly what we got from the asteroid regolith. This mission continues to amaze me and everyone involved here. The engineering is ingenious for this mission, getting us with a robotic explorer to the edge of the solar system, collecting that sample, safely stowing it, and then actually transporting it back here to Earth for us to open up and analyze. The surface today was probably a little bit soft, so it looks like it's resting a little bit far off the actual desert. It doesn't appear to have dug in too much with that nose cone from the heat shield. You are here with us as we witness this historic moment. It's the first time the United States has delivered samples from an asteroid to Earth. And these samples will be analyzed for decades to come in laboratories around the world. And there is landing of our first helicopter at the site. Appears to have a nice soft landing. We're just probably a couple hundred feet.
Recovery operations. Helo 1 has landed at the recovery site.
So our first helicopter, you just heard confirmation, and you can see visual confirmation of that landing. We're maybe about 100, 200 feet away, landing away from that sample. So a little bit of a hike for our team members to get out to that sample return capsule and begin our environmental safety sweep. As I mentioned, our on-scene commander, Stu Wiley, will be the first person of the team to actually approach this sample, check the area for any unexploded ordnances, UXOs, that could possibly be out there on the range, and then also make sure that that SRC is safe for our operations team to approach and begin recovery. You can see where that parachute disconnected from the top of that SRC. That is the back shield that you see right there at the very top with that little bit of white wiring still coming out of the top. Our SRC perfectly landed there on the Utah Test and Training Range. So what you're about to see happening next is the process of recovery operations. This is a key moment of today's events to actually get that SRC from out in the desert into our portable clean room here at Dugway. It is crucial that we maintain the pristine nature of this sample that we got back from asteroid Bennu. It could hold the clues to how everything around us came to be, from the formation of the planets to origins of life here, so the team understands just how crucial the contents of that SRC is, and they're going to work as efficiently and as safely as possible to get that SRC contained, wrapped up in thermal blanketing, placed in a sample carrying fixture, and then attached with long line to our first helicopter there. It'll then be transported the long journey back here, a much more relaxing flight, I'm sure, for our SRC, to our portable clean room at Dugway. At which point the team members will extract the back shell and remove the heat shield from the SRC. It's served its purpose. We're mainly now concerned with getting the contents within that sample canister containing pieces of the asteroid regolith out of that SRC. We won't actually, as I mentioned, be opening that sample canister just yet here at Dugway. The team is simply focused on getting that SRC, or the sample canister rather, on a nitrogen purge, and this is to maintain that pristine nature and prevent any kind of contaminants from the atmosphere from getting into our sample within.
Recovery operations. Kilos 3 and 4 have been cleared to land at the recovery site.
And the rest of the team is closely behind, ready to land at the recovery site to begin operations. This will be simultaneous action that you'll see here once we have the clearance from Stu Wiley to begin our recovery operations. At least from this perspective, I'm not noticing really any drag marks or any kind of roll marks, but the team, once they approach, will mark any possible areas of interest where the SRC possibly came in contact with the rough desert terrain. All of these regions will be sampled by a recovery team and will be passed off to the sample curation team at the Johnson Space Center. As they begin to unload and actually open up the sample canister there, exploring the contents within and making sure that no possible contaminants from the surrounding landing location got into our sample. We're getting a wider view now. We should have the helicopters that have landed nearby coming into view potentially. The team really taking extra precaution as they approach the SRC. As I mentioned, team member safety is paramount during these operations. There are possible potential areas of concern as the team begin these operations, including the temperature of that SRC. You see it looks quite charred there. It could still be a little bit warm. As I mentioned, it heated up to over 5,000 degrees Fahrenheit. So as the cool desert air begins to cool down that SRC, we want to make sure that it is cool enough for our team to actually begin those recovery operations. We'll also be checking the gas levels of that SRC to make sure that it is not outgassing from the batteries within, heating up during that reentry. We'll also be making sure that there is no live voltage present. And we see a view now from our high altitude plane that has visual of those helicopters landed nearby, just at the northern part of your screen. You can see one of them on screen now. The top of your screen there, it is centered up. There is our helicopter, and it appears that we have our on-scene commander potentially walking over. This is once again our high altitude WB-57 shot of our helicopters landed at the LZ, our landing zone. You can see some movement on the screen. It appears some team members might be approaching our SRC at this point to begin those recovery operations, the initial safety sweep. We'll just be observing from this high altitude for the next coming minutes as the team actually will be setting up a camera on the ground for us to observe the recovery operations close up. And a note from one of the team members about the SRC itself. So they have approximately 40 hours. That is the amount of time it would take for any air to get into the sample. As I mentioned before, that sample return capsule is a complex network of piping and tubing inside of it, sort of like a labyrinth-like design. And that is intentional to make it incredibly difficult for any possible contaminants from the atmosphere to get into our sample canister. It's also sort of like a nesting doll, if you will, where it has multiple layers of protection that keep that sample safe within. All of that protective layering, once we get that sample into the clean room, will be shed, and we'll be able to actually access that sample canister within. The main goal, as I said, for today is to get that sample canister on a nitrogen purge. That is to maintain its pristine nature. And we have visual once again from one of our helicopters here orbiting around the landing location. You can see our SRC at the bottom left of your screen and its parachute that helped us get the last leg of the journey down. It deployed a little bit higher than we expected, 20,000 feet elevation. Original expectation was at about 5,000 feet. And this brought us down the last leg of the journey after a punishing initial entry into Earth's atmosphere over San Francisco, about 82 miles in altitude, to now resting on the rugged Utah Test and Training Range desert floor.
Recovery operations. Recovery team is in the vicinity, beginning their initial assessments.
So you just heard confirmation from Tim Preiser that the team is beginning to actually approach the SRC for that initial environmental and safety sweep. You'll soon see our on-scene commander, or Oscar, Stu Wiley, approaching that sample return capsule. As I mentioned before, he'll be checking for any possible unexploded ordnances. You can see our mission operations team. They have been overseeing all of this morning's events, and they're going to continue. There we go on screen. You can see front and center there, Stu Wiley, our on-scene commander, and right behind him is Victoria team. They are both wearing personal protective equipment, gas masks. That's for their own safety as they approach, as there could be potential outgassing from that sample return capsule's batteries heating up during re-entry. You can see him scanning the region. He's checking for any possible unexploded ordnances, UXOs.
Recovery operations. Oscar is performing the unexploded ordnance survey.
And you just heard that he is in fact doing that survey right now. You can see him walking around the SRC. This is the first person to come in contact with this SRC since it was on the other side of the solar system. We had sent this on a long journey, the OSIRIS-REx spacecraft. Finally delivering the sample, he is motioning over to Victoria team, who is shortly going to approach and begin taking some gas and thermal readings. You can see her walking over and must have given the clear for her to proceed. A little bit closer, Stu continues to pace around the surrounding area. All over here, the team will collect samples. He'll begin to place flags. You can see in his backpack, he's got a couple flags waving in the breeze. Those will be placed at areas of interest for our team members to sample once they arrive and begin those recovery operations. Victoria is now appearing to take out her thermal and gas reading devices. She's taking an initial thermal reading of that SRC as we speak, looking for it to be at an operational temperature of around 100
Recovery
degrees Fahrenheit.
operations. Lockheed Martin Safety is performing hazardous environment assessments.
And you just heard that confirmation. So she is performing that hazardous environment assessment, checking the thermal temperature of that SRC, as well as taking any kind of gas readings to make sure that we are at safe operational levels. She is also leading over. This is Victoria team from Lockheed Martin. Stu continues to sweep the area around her for the safe operation of our recovery crew members. There are several nozzles, valves around the SRC, and so once Victoria has the clear to approach, she'll actually open up some of those valves and insert a gas reading device within to actually take some temperatures. And you can see off to the left of your screen, Stu Wiley is actually safing and stowing away that parachute that helped take us the last leg of the journey. It's great news that that disconnected from the SRC, that allowed our SRC to rest as it is now here on the surface of the Utah Test and Training Range. It appears with minimal dragging.
Recovery operations. Oscar is safing and storing the main parachute.
So Stu is going to get that parachute stowed, placed away, as Victoria is front and center on your screen, beginning to take some of those gas readings to make sure that we are not outgassing any kind of noxious chemicals that could be present from that battery heating up within the SRC. And Stu is walking back to the team with that parachute. So the SRC battery is comprised of lithium disulfide, and as such, the possibility of toxic vapors exists if the battery packaging has been damaged during entry or landing. Discharging could cause a potential presence of hydrogen sulfide from those batteries heating up, or carbon monoxide. And so that is why Victoria initially had her gas mask on. It appears she has now actually taken it off, so it appears that the gas readings indicate nominal conditions.
Recovery operations. Lockheed Martin Safety has confirmed no hazardous gas.
And you just heard that confirmation, so the safety assessment is successful. Victoria has confirmed that with her gas readings and thermal measurements of the SRC. They'll then go back over, Stu and Victoria, for a team huddle to prepare the rest of the team to begin the recovery operations and actually get this SRC into our clean room here at Dugway and continue the operations. You can see the Lockheed Martin team, the bottom left of your screen, just overjoyed with this moment. This is years of careful planning and preparation leading to this final phase of getting that sample back here to our clean rooms. I'm sure they've been holding their breath all morning, so they're getting closer to finally being able to take another breath and relax as we actually will begin our recovery operations, a key part of today's events. And you might see Victoria approach over and over once again to that SRC to continue to take gas readings. At this point, she appears to be covering up the back shell of that SRC, placing a Teflon cover over. This is where the parachute actually deployed, at the top of the SRC capsule, the sample return capsule rather. She'll also be checking for any possible live voltage. And we'll wrap Kapton tape around the two cut cable ends protruding from the back of the SRC where that parachute deployed. You can see her with that covering as we speak, placing it on the back shell. And she has successfully placed that shielding on the back, that Teflon cover. Stu walking around behind, checking the rest of the scene, walking back with the parachute that he now has safely stowed away. And you'll see Victoria opening up a couple gas valves on the SRC, taking those gas readings. Continue to do this throughout the whole process. She's also placing covers on those gas vents too to prevent any kind of contamination from atmospheric particles, particulates entering into that SRC. She's photographing the scene as well too. This is to keep careful note of exactly the procedures that she's going through for her team. So the recovery operations will be getting underway shortly now that the team has conducted their initial environmental and safety sweep. Everything appears to be nominal, which is fantastic. We do, in fact, have that SRC on the ground. The rest of the team will be approaching shortly. But for now, back to you, Lauren and Jim.
Wow. Thank you, James.
Oh.
Can you believe it?
OMG. Touchdown for science. What a great day.
For the folks at home, this is a huge deal, and they did it.
For the first time in history, we brought goodies back home from this kind of object in the history of humanity. So this is big.
This is so huge, and we're all breathing a big sigh of relief. Obviously, we're not completely out of the woods here, and we'll be monitoring what's going on and keeping you abreast of everything that's happening. But for now,
wow,
we made it home.
A great job by that Lockheed Martin team safing that craft.
Fantastic.
What a spacecraft. We have to name her specially.
Yes, absolutely. In that capsule, everything perfect. So while the capsule was making its way to the ground, mission teams
recovery operations, all vent covers are in place.
All right, so we're making progress.
We're making progress.
All right, so while the capsule was making its way to the ground, mission teams in the Colorado control room and the mission ops area here in Utah were, of course, riveted by the live images. These teams have watched and nurtured this mission for more than 7 years of spaceflight, and even longer in terms of construction and design. Gosh, wow, amazing.
11 years since it was selected to fly. What a job, folks.
Just fantastic. A lot's happened in 7 years. All right, so let's get an update from where the action started this morning. Sophia, tell us everything.
Okay, firstly, I want to say we are so grateful that the capsule is on the ground and in good hands now. Now, from here, from Whig Mountain, I am overlooking the vast landing zone, which, again, is larger than the state of Rhode Island. So, during that time, listening to James's commentary of the capsule coming through our atmosphere, we're all standing on the edge here, looking and scanning through the sky. But just to give you some context again of where I am, I'm about 4,000 feet up, overlooking a vast, ancient seabed. So the mountains that are peppering along the edges over here, they are very muted colors. It's a beautiful pastel out there. And as we're looking over through the sky, it's hard to see because there's alkaline dust from this ancient seabed. And considering that the capsule has landed on the edge of the landing zone, even though I'm as close as I could possibly be, I didn't see anything over here. I will say I'm a little disappointed, but grateful that that capsule is in the most capable hands it can be, and that is the most important thing out here. So while I didn't see with my eyes myself, we saw it on the screen, and it's still a great day. So back to you, Lauren.
Wow, thank you, Sophia. And thankfully, we got that great image from the NASA helicopter. Wow. Just well done to that team. Thank you for that. So while we're keeping an eye on ongoing operations to prep for the SRC transport, we have a special message from someone who keeps a close eye on the entire manifest of the space agency's travels around the solar system.
Hey, everybody, congratulations to the OSIRIS-REx team. You did it. You designed it, you built it, and you carried out the first mission to collect a sample from an asteroid. And after a 2-year journey, it has touched down at the Utah desert. It brought something extraordinary, the largest asteroid sample ever received on Earth. It's going to help scientists investigate planet formation. It's going to improve our understanding of asteroids that could possibly impact the Earth, and it'll deepen our understanding of the origin of our solar system and its formation. This mission proves that NASA does big things, things that inspire us, things that unite us.
Recovery operations, we can confirm that the SRC is not breached.
Beyond our reach. And the mission continues with incredible science and analysis going to come. But I want to thank you all for everybody that made this OSIRIS-REx mission possible. It wasn't mission impossible. It was the impossible became possible. Thank you all.
And just as a reminder, we are keeping those operational milestones going, so you will continue to hear that throughout the broadcast. Thankfully, the SRC was not breached. Fantastic, fantastic news. All right, as anyone who pays just even a little attention to modern spaceflight knows, there has been more activity above the planet in recent years than ever before in human history. There are probes like OSIRIS-REx moving around the solar system, observatories looking out into deep space, and satellites closely examining the health and future of our own planet. There are also human explorers, and we are so fortunate to have 2 of them with us here today. Joining us now are NASA's astronauts Butch Wilmore and Sunny Williams, scheduled to launch on Boeing's crew flight test aboard Starliner to the International Space Station. Butch and Sunny, thank you for joining us.
We are honored to be here.
Super exciting day.
What a thrill.
Congratulations.
Absolutely historic. How are you feeling?
Pretty amazing.
It was like, wow, this is what, dreams and imagination is fueled with. This is just amazing. So, it can go from the movies, but this is reality, and we're doing things that people couldn't even believe could happen. It's amazing. Yeah.
And also, we've both landed under capsule, under parachutes. There's not much better feeling when that parachute opens, I'm telling you. And it was maybe not equal, but pretty close to exciting and the tense and that parachute opened. Oh, it was thrilling. Absolutely thrilling.
Yep.
Yeah, it's fantastic.
Well, that is fantastic. One of the things that I think will be really interesting is this, of course, this site is being considered as one of the candidates for the Boeing Starliner crew flight.
Right, and that's actually why we're here. It just worked out in our timing for our training and as we're working on Starliner, that we could come and actually view one of our prime landing sites, which is here at Dugway. And so that's actually what brought us to the area, so we could be here and sharing the experience with you today.
And we see this has gone so well, we are ready to land.
Recovery operations.
That's the place that our flight
The recovery team is performing their safety.
This is a beautiful place. It's a beautiful day this morning. No wind. I think the capsule just came right down under the chute, and hopefully we'll have a nice soft ride just like this capsule too.
Absolutely. And we just got a call out that the recovery team is performing their safety operations. Everything nominal.
So you guys will be coming back, and maybe someday with samples yourself, brought back by humans.
Indeed.
What do you think about that?
Again, we're in that era of going beyond low Earth orbit now with humans, headed back to Moon and potentially one day to Mars with the Artemis program. And it is a thrilling time, as you mentioned earlier. So much taking place within the solar system, the near solar system now, and it's fascinating. Great time to be in human space.
Awesome.
I think I'd be a little bit nervous to go to an asteroid, so,
Wise woman.
I'm super glad the spacecraft did it, and we'll set the pace and show us how to do it. But I think maybe you'll practice a little bit more before we go, because it's a dangerous environment learning about it.
So much Sunny and Butch, thank you so much for joining us today. Hopefully you'll stick around for more of the show.
Yeah,
all right, congratulations
thank you guys.
everybody out there.
Really appreciate it. Thanks, guys. Good luck with your flight.
If you've just joined us, this is special live coverage of NASA's OSIRIS-REx asteroid sample return mission. You might be thinking, this doesn't look like a typical NASA facility. And it's not. In fact, it's because of the extraordinary capabilities that we find here that we find ourselves in the Utah desert in the first place. We're coming to you live from Army's Dugway Proving Ground. We've got a video postcard to share that will give you a better sense of the glorious desert environment all around us. Take a look. Wow, absolutely gorgeous. The spaces here are vast, rugged, beautiful. I mean, you got to see a little bit from the NASA helicopter, but that was a close-up and personal look.
And look at this. We're in this place that almost looks like Mars, but on Earth, as we're recovering a capsule with the pieces of our universe that will tell us about the early time of our solar system that we can't get anywhere else. And there's the crew out there approaching that beautiful capsule that did the joyful ride from that top of the atmosphere down. 13 minutes of roller coaster riding, and they're getting it safe and ready to start bagging her to come over to the clean room here.
Wow. And explain, why do we do a land landing, as opposed to an ocean landing?
Right. So many of our crews land in the ocean, as you know from Apollo. But for this one, we need to bring it back to a place where we can contain the contamination. By landing in the desert here, we can keep the Earth's ocean, all those absolutely wonderful waters out. This is the best place to bring home this kind of capsule. And look at her. She landed perfectly. Looks like a top sitting there.
Absolutely gorgeous. Well, this isn't the first time that NASA has visited Dugway, and it certainly won't be the last. Take a look. When bringing a sample of the cosmos back to Earth, it's important to find a good landing zone that won't compromise the sample. That's why NASA partnered with the Army's Dugway Proving Ground. Its vast open space makes it ideal for the task. But OSIRIS-REx is neither the first nor the last mission to land here. In 2004, the Genesis mission landed here at Dugway, delivering our first ever samples of solar wind. In 2006, NASA landed at Dugway again, this time with a mission called Stardust, which gathered samples of interstellar dust. Both of these missions helped fuel our understanding of the universe and wouldn't have been possible without a safe landing zone, just like OSIRIS-REx. After today, NASA and Dugway are looking towards the future, to the Mars sample return mission that will once again be bringing a unique sample of our universe right here to Dugway Proving Ground. The U.S. Army and Air Force have been excellent hosts to us for months as we've been preparing for today's landing. That's one of many reasons I'm so pleased to welcome Colonel James Harwell, Army Commander here at Dugway Proving Ground.
Recovery operations. Nominal SRC recovery operations have begun.
Getting an update. Okay. All right, nominal SRC recovery operations have begun. Okay.
Pretty darn good.
All right. Okay, so today could not have gone any better. How did it, in large part due to our amazing partners here with the military, how did it look from your end?
Oh, it looked amazing. So when you talk about partnerships, this isn't just a Dugway Proving Ground effort. Though you're sitting here on Dugway Proving Ground, the capsule actually landed on the Air Force's Utah Test and Training Range, and so it's going to be brought here to Dugway before it goes to the clean room. So this is a larger effort than just the Army's Dugway Proving Ground and NASA.
And it looks like it might have landed right
So I got a note just before this from the commander of the Utah Test and Training Range that it did land on Uter. And so there was a little bit of rivalry there. We were hoping, but it looks like it was on Uter.
Right on the boundary, though.
Yeah.
So close.
So we have a big collaboration at NASA with members of from the Army and Navy, from the military services that have given us the opportunity to go to these great places in space ourselves as people. And can you tell us a little bit about the training and other fantastic things you do prepares these people to be crew for flight into space?
Yeah, so if you look at it, the Army is the greatest leadership lab in the world, the types of problems that we have to solve on a day-to-day basis. And we have some of the best workforce that is available. So here at Dugway Proving Ground, we do chemical and biological defense testing. We're part of the Army's Test and Evaluation Command. And so anytime a piece of equipment is going to go into a service member's hands, it's tested by one of our amazing members of our workforce. But we also do training here. And so it gives a chance for folks to come and do things in a realistic environment. And that's really allows them to hone those problem-solving skills.
So that's why the crews are so good who come from the Army and the Navy and Air Force.
Yeah, we'd like to point out it was an Army astronaut this week who went over who set the record.
Oh, well, there you go. Well, we couldn't let you go without wishing you a very happy birthday today. Happy birthday. Today is your birthday, and you got a piece of the solar system. How about that?
I don't think I could have gotten a better present from NASA.
No. And this is the rarest stuff we've ever had on Earth.
It is. And I mean, when we're talking about the origins of life, and that's one of the I have the coolest job in the world. A couple months ago, I was here, and out on the Utah Test and Training Range, we got to go out to an archaeological site and see 12,000-year-old footprints. And now we're going to get to see the material from the origins of the solar system. I think we've set the bar pretty high, and so my kids think I'm cool today. I don't know what we're going to do to top this.
Well, we think you're pretty cool, too.
Yes, yes, sir.
And thank you so much for joining us. We've really loved having you.
Thank you so much.
We have a saying at NASA that the only way to reach the stars is if we all go together. The OSIRIS-REx team represents pros at the top of their game, but future explorers are just now finding inspiration in today's events. Here at the Dugway Proving Ground, students attending public school can literally say that a sample of an asteroid landed in their backyard. We visited the school to hear their thoughts about the mission and how their teachers hope it might influence their dreams of future exploration.
My name is Deborah Rockmore, and I am the librarian here at Dugway Elementary through High School. I love that Dugway is part of this. We have a very strong feeling about Dugway. It's a wonderful base. To have it be a prominent area where this is coming down is really amazing to us.
Well, I'm just glad that this little town is getting noticed. It's a big rock that has kind of like holes in it because they've been flying through the sky with fire because it goes really fast.
Honestly, I find it really cool because you don't really expect this stuff to happen, you know, in your backyard. But I really wish I could see it, but I don't know. I'm going to try my hardest.
I became interested in this